Okay, so now let's go ahead and create our game server. So I will create a new class for that, which I will call game server. And then I would like to import java.io.asterisk and import java.net.asterisk. Okay, so let's go ahead and create a couple of fields. So I'd like a field for my server socket, and I'd like an integer that will keep track of how many players we already have, and another one to set how many players are allowed. Okay, so let's call that one max players. And then let's go and create our constructor, game server. So let me just put some feedback, system.out.println. And this one is just going to say game server. And then we set num players to 0 because we want to start off with 0 players. And for max players, we will set a limit of 2 players. Okay. Then we need a try catch to instantiate the server socket. So ss is equal to new server socket. And then for the port number, I will just choose 45371. Okay. And then we put in the catch clause, IO exception. So let me just put system.out.println. IO exception from game server constructor. All right. Then let's go ahead and create a method that will encapsulate the accepting of connections. So we shall call this accept connections. Okay. So what do we put in here? So we need a try catch. Okay, so let me just put system.out.println IO exception from accept connections. Okay. So first thing I want to do is I want to give some feedback. Let's just put in system.out.println, and then we'll just say waiting for connections. And then we put in a while loop. While num players is less than max players, we want to keep the while loop running. Okay, so what do we want to put in here? We want a call to the accept method of the server socket, right? So that one returns a socket. So socket s is equal to ss.accept. So this is the line that tells the server to begin accepting connections. So as long as no clients have connected yet, the program is going to stay in this line. Okay, so once a client has connected, let's go ahead and get the input and output streams. Okay, so data input stream, let's just call this one in, is equal to new data input stream, and then s dot get input stream. Okay. Then we do the same thing for the data output stream. Out is equal to new data output stream s dot get output stream. Okay. So once a player has connected, we can go ahead and increment num players. So the first time a player connects, numplayers becomes 1. And then we'll use that to determine the player's player number. So we want to write out the integer. Okay, so out is our data output stream, and then write int allows it to send an integer to the client. So we just want to send the current value of numplayers. So the first time that happens, it's 1. So we say system.out.println. Then let me just say player number plus numplayers has connected. So again, the first time this happens, it's going to say player 1 has connected, and then the next time it happens, it's going to say player 2 has connected. And then after player 2, the while loop breaks, and then we can just say no longer accepting connections. All right, so that does it for the server. Oh, but of course we have to go ahead and make the main method. So public static void main string args. Okay, so let's instantiate the game server. Game server gs is equal to new game server, and then you want to call the accept connections method. Okay, so that's it for the server for now. Okay, then let's move on to the player frame, and let's add the code that allows it to connect to the server. Okay, so we want to import java.io and java.net here as well. Okay. So let's add a field here. So a field for the socket. And just call it socket. Okay. Now let's go ahead and create a method called connect to server. Okay. So private void connect to server. So this one will have a try catch as well. System.out.println IO exception from connect to server. Okay, so what do we want to do here? We'd like to create a new socket that's going to initiate a connection to the server. So socket is equal to new socket. So for now, I'll just put in localhost since I will be testing it in my computer. And then for the port number, so I chose earlier on, I chose 45371. Okay, so this initiates the connection. Then you get a socket back, right? So once the connection is established, we get the input streams as well. Okay, data input stream in is equal to new data input stream socket.get input stream. And then we do the same thing for the data output stream. Okay. So this one is the output stream. Okay, so make sure you change all of the ins to outs. Okay, so if you remember, the first thing our server does is it sends an integer for the number of for your player ID. Okay, so we need to go ahead and accept that using a read. Okay, so player ID, right, is equal to in.read int. So whatever gets sent by the server, whether it's 1 or 2, will be our player ID. And I'm getting an error here because I actually forgot to declare my player ID. So I'll go back up to the fields here, and then I'll say private int player ID. Okay, so now we have the player ID field. So the player ID field only gets a value after we actually connect to the server. Okay, so the server needs to tell us whether we are the first one to connect or the second one to connect. Okay, so let's put in some feedback. System.out.println. Okay, you are player number, and then we just add the player ID value. Okay, and then if you are player number 1, let's add in some extra output here. If player ID is equal to 1, okay, so we're just gonna say system.out.println. Let's just say waiting for player number 2 to connect. Okay, so now that we have the method, let's not forget to call this one. So I want to call this one before I set up the GUI, because when I set up the GUI, I want to know my player ID already so that I'll know if I'm the blue square or the red square. So pf.connect to server. All right, so at this point, I think we can go ahead and test this. Okay, so let's run the game server. So there it is, game server waiting for connections. And then let's run player number 1. Okay, so you are player number 1 waiting for player number 2 to connect. Okay, so let's run another instance. Okay, so run file, there. You are player number 2. Then if you go to the output window for the server, it should say player number 1 is connected, player number 2 is connected, no longer accepting connections. All right. Okay, so now that we are able to get our player ID, let's use that to set the correct title. And let's also use that to set player 1 to be the blue square on the left, and player 2 should be the red square on the right. Okay, so let's just close all of these processes. Okay. All right. So in the player frame, let's go back up here to the fields, and then let's add another player sprite for the enemy. Okay, so let's call that one private player sprite enemy. So you're always going to be me, right? But if you're player 1, me is going to be the blue square on the left. If you're player 2, me is going to be the red square on the right. So where do we instantiate the sprites? So there is a create sprites method over here. Okay, so we call the setup GUI method, and then it sets the title, which at this point we can actually go ahead and set to the correct player ID, right? So player number plus player ID. Okay, so remember that we are calling connect to server before we set up the GUI. So by the time we call setup GUI, we should already have the correct player ID. Okay, so after we've set the title, we go ahead and edit the create sprites method so that it actually draws 2 squares, one blue one and one red one. So inside the method, okay, let's put in an if statement. If player ID is equal to 1, okay, then we actually keep this. Me is equal to new player sprite. It's going to be the blue square, which is on the left side. So it has an x of 100 and a y of 400. Okay, so if you are the blue circle, this means that your enemy is the red one. Okay, so when we instantiate an an enemy player sprite, we give to it different coordinates and a different color. So this one is going to be the one on the right. So let's give it an X value of 490. So this puts it to the right half of the stage. And then for the Y, let's keep it at 400 as well. And then let's give it the same size. Now for the color, we make this one red. Okay. And then in the else clause, so if you are player 2, then it's just the other way around. Okay. So if you are player number 2, then, okay, so let's just switch this. So if you are player number 2, then the enemy becomes the blue square, and then you become the red square. Okay. And then we have to go to the paint component method and actually draw the enemy sprite as well. So enemy dot draw sprite G2D. Okay, so now if we run this, we should be able to get 2 squares already. Okay, so the server is running. Okay, so player number 1. So you are the blue circle here. So if I press the up and down arrow keys, it's the blue circle, or the blue square, sorry, the blue square that should move. Correct. Then let's run another instance of the player. So this one is player number 2. Okay, so player number 1 is over here. Player number 2, so if I move the up and down arrow keys, it's the red square that moves. All right, so let's go ahead and close these processes now. And then we'll edit the next part. So in our finished product, whenever each player moves in their own console, they also move in the other player's console as well. So our approach for that would be, we are going to make it so that each player will be constantly sending their X and Y coordinates to the server, and then the server is going to pass those coordinates to the other player so that the movement gets updated for each player. In order to do that, we are going to need to have separate threads for the writing of the information and the reading of the information. So if we go back here to the game server, we are going to need to create 2 runnables and then run 2 threads for each player. So we'll end up with 4. So the reason why we need to do that is because the reads, the nature of reads is that they block whenever they don't have any information to read. So we want to make sure that the reads are separate, otherwise they could potentially mess up the other parts of the code. They could interfere with the writing and also the GUI updates. Okay, so we are going to create inner classes for the runnables. Okay, so an inner class for writing and an inner class for reading. So let's do that for the game server first. Okay. So private class, let's call this one read from client. So this is going to be the runnable that's going to read information from the client. So the client is going to be sending the X and Y coordinates, and this runnable is going to manage reading all of those information being sent. So it should implement runnable. Okay. And then we are going to put a couple of fields here. Private int player ID. Okay. So this allows us to differentiate whether it is the runnable for reading the information from player 1 or the one for player 2. And then of course it's going to need the data input stream, okay, which we will call data in. Okay. And then we create the constructor read from client. So we pass to it the player ID and then the data input stream as well. Okay, so player ID is equal to PID, and then data in is equal to in. And then just put some feedback, system.out.println. Let's just say RFC for read from client, and then we add to it the player ID so we can see whether it's RFC1 or RFC2. And then we just say runnable created. And then since Since this implements the runnable interface, we need to put in public void run, but we'll fill that out later on. Okay, so now that we've got the read from client runnable, okay, so let me just copy that and make the one for the writing to the client. So I'll call this one write to client. Okay, so you're going to need a player ID as well. If you are player ID number 1, then you want to write the X and Y coordinates out to player number 2 and vice versa. So for this one, we are going to need the data output stream instead. Okay. So public write to client. Okay. So data output stream out. And then data out is equal to out. For this one, I will just change it to WTC for write to client. And then we have the run method as well. Okay, so now that we have these inner classes, let's go back up to the field and add a couple more fields. Okay, so we'll need fields to reference the runnables and also to store the socket. So private sockets, so we'll actually have 2 sockets, right? There's one socket for player 1, and then another socket for player 2, P2 socket. So you want to store references to them, so eventually you can close them when the game ends, okay? And then we create the fields for the runnables, okay? So let's create the ones for the read from client objects first. So there's going to be one for player 1. Let's call this one read runnable. Okay. And then read from client. So there's another one for player 2 as well. And then we go ahead and make the ones for the write to client. Okay. So there's P1 write runnable, and then there's also another one for player number 2. Okay. P2 write runnable. Okay. And then we need to go back to the accept connections method. So this is where we actually assign the correct values to these fields that we have here. So back here in accept connections, so after we've sent the player ID to the player, we'd like to go ahead and create the read from client and write to client objects. Okay, so read from client, let's just call this one RFC, is equal to new read from client. And then we just pass to it the current value of num players. So it's going to be either 1 or 2. And then you give it the data input stream. And then for write to client, okay, let's call this one WTC is equal to new write to client. And then we pass to it the current value of num players as well. Num players and the data output stream. So we've already gotten the socket, the data input stream, and the output stream here. So we just pass the input stream and the output streams here so that the read from client and write to client objects will be able to access them as well. Okay, and then we need to go ahead and create an if-else statement so that we can properly assign the correct object to these fields. So if you are player 1, then you want to assign to the player 1 fields, and if you are player 2, then you want to assign to the player 2 fields. Okay, so if player ID is equal to 1, then the socket, this one, okay, goes to, oh, sorry, not player ID. We're not using player ID here. We're using num players. So whatever the current value of num players is, okay? So if num players is equal to 1, in other words, if you are player 1 or the first player to connect, P1 socket, okay, is going to get the socket that has just been created. And then P1 read runnable is going to get the read from client object that has just been created, which is referenced by RFC. And then we've got P1 write runnable. So this one is going to be equal to WTC. Okay. Then in the else clause, we just assign it to the player 2 values, okay? Or the player 2 field rather. So P2 socket is equal to S, and then P2 read runnable is equal to RFC, and then P2 write runnable is equal to WTC. Okay. So that is it for the game server for now. We need to go to the player frame also. And player frame is also going to need separate threads for writing and reading. Okay. So in the player frame class, we go ahead and create the inner classes for the runnables also. Okay. So let's go here. Okay. Private class. Let's call this one read from server. Okay. It implements runnable as well. Okay. So for this one, we just need the field for the data input stream. Okay. So we don't need the player ID anymore because we actually have it here, and our inner classes will have access to the top level fields. So, okay. Then we create the constructor read from server. So this one, we just need a parameter for the data input stream. Okay. We say data in is equal to in. And then we just put in some feedback that says system.out.print line. And then we're just going to say RFS runnable created. Okay. Then we go ahead and override the run method as well, but we'll add stuff to that later on. Okay. So now that we have this, we just copy that and make the inner class for the writing to the server. So let's call this one write to server implements runnable. Okay, so this one, we are going to need the data output stream instead because we are writing out to the server. Okay, so data out. Okay. Write to server. Okay. Data output stream out. And then data out is equal to out. System.out.println WTS runnable created. Okay. And then let's go back up to the fields and let's create fields for the runnables. So there's read from server. So we'll call this one RFS runnable. And then private write to server. Let's call this one WTS runnable. Okay. So when do we create these runnable objects? We do that in the connect to server method. Okay. So it's right here. Okay. So after we've received our player ID, okay, let's go ahead and instantiate the RFS runnable object. Okay. So new read from server. And then we just pass to it our data input stream, which we have here. Okay, so we just pass to it in. Okay, and then we do the same thing for the write to server WTS runnable is equal to new write to server and then out. Okay, so at this point, let me just test my code. It's not going to do much because we actually are not sending the x and y coordinates yet, but we should get the feedback where we get to see if runnables actually get created. Okay, so let's run the game server first. So waiting for connections. Let's run player 1, so first player to connect. Okay, you are player number 1, and the player 1's runnables have been created. And then if we go to the server output, it also says RFC1 and WTC1 runnables have been created. So let's go ahead and run the second player. So this is player number 2, has its runnables, and the server also created the runnables for the second player as well. Okay. Okay, so we are now ready to send out the x and y coordinates of our players. So let me just close these windows. Okay, so let's go back to the player sprite, and then we'll see that we have a couple of methods here. Get x and get y allows you to return the x and y properties of the sprite, and then set x and set y allows you to change the x and y values. Okay, so we're going to be using that for sending and receiving the x and y. So inside the run method of the write to server runnable, okay, so we want to put in a try catch. So this is where we will be constantly sending out the x and the y coordinates of our player sprite. Okay. So system.out.println IO exception from WTS, right to server run. Okay. So inside the try section, you want to put a while loop because you want to constantly send your x and y values so that you keep updating the server as to your whereabouts. Okay. So you use the data out object, and our x and y coordinates are double, so we use write double. And then our player sprite is referenced using the me field, and then we use the getX method of the player sprite class. So that sends the x, and we want to send the y as well. So me.getY. Then data out.flush. Okay. So this while loop is pretty fast, so right, as all while loops are. So if we don't slow the while loop down, this is going to overwhelm the network because we're simply looping and looping and sending out the doubles. Okay, so we want to slow down the while loop a little bit. Okay, so this runs in a thread. So we can do that by using the thread.sleep method. So inside the while loop, after you send out the doubles, you want to have the thread sleep for a bit so that it kind of relaxes a little bit, and then sleeps and then goes back up and then sends the double again. Okay, so it's not going to be as fast as the while loop that doesn't sleep. Okay, so we need a try catch for that as well because our thread.sleep call throws an exception also. So it throws an interrupted exception. Okay. So we just say system.out.println, and then we just say interrupted exception from WTS run also. Okay. And then we just make the thread sleep for a couple of milliseconds just to slow it down slightly. Okay. All right. So there. So now with the thread.sleep, it isn't going to overwhelm the network as much. I mean, there still is probably going to be a little bit of lag. There are many other ways to fix that, many other approaches, but we'll stick with this one for now. Okay. So this is our write to server runnable. In the run method, we are sending the x and the y of our player sprite. So in the game server, we need to receive these x and y coordinates. Okay, so let's go to the game server now. And inside the part where we have the fields, we need to go ahead and add a couple more fields. So we need to add fields for the x and y coordinates. Okay, so private double. So we want fields for the player 1 X, player 1 Y, and P2 X and P2 Y coordinate. So we want to store them and then send them out to the other player. Okay, so P1 gets P2's X and Y, P2 gets P1's X and Y. Okay, so we want to do that here in the read. Okay, so we want to receive what the player frame has been writing out here in the read from client run method in the game server. Okay, so inside here we want to put a try catch as well. So system.out.println IO exception from RFC read from client run. Okay, so here we need a loop because we also constantly need to receive those values. Okay, and then inside the loop you want an if statement. Okay, so if you are the runnable for player 1, if player ID is equal to 1, then you want to read the doubles being sent to you, and then you want to assign it to P1X and P1Y. So P1X is equal to data in dot read double, and then P1Y is equal to data in dot read double as well. Okay, and in the else clause, we do the same thing for P2X and P2Y. So P2X and P2Y. Now in this case, we don't need to make the thread sleep because our reads will automatically block until we actually get some information. So since we are sending the X and the Y with a 25 millisecond break in between, it follows that the reads are going to happen in a somewhat similar time, depending on things like the lag and such. Okay, all right. So now that we are able to send the X and the Ys of our players to the server, we are now going to send them back to the client, right? So player 2 gets the P1X and P1Y values, and then player 1 is going to get the P2X and P2Y values. So let's go to the write to client runnable. Okay. So here we put in a try catch as well, right? So try catch IO exception EX, and then we say system.out.println, and then we just say IO exception from WTC run. Okay. So inside here, we need a while loop as well, right? Because you want to constantly send out the updated X and Y values to the other player. So while true, we put in our if statements inside. So if you are player ID number 1, then you actually want to get the P2X and P2Y values. So you say data out dot write double, and then you want to send out P2X and P2Y instead. So the other player actually gets the coordinates of the other player. Okay, so P2Y, and then you do oops, I forgot my semicolon. Okay, then we do a flush, data out dot flush. Okay. Otherwise, if you are player 2, then you go ahead and send P1x and P1y instead. So P1x and P1y. Now, whenever we write, so we want to do the thread.sleep, right, in order to slow down the loop. Okay, so try thread.sleep and then say 25. You can slow it down a bit more if you want to reduce the network congestion or the network traffic you will be creating. Okay, so interrupted exception ex system.out.println interrupted exception from WTC run. Okay, so now we have to go back to the player frame and receive the information being sent to us by the server. Okay. In the game server, I think it would be a good idea to initialize the values of our P1x, P1y, P2x, P2y. So in the game server, let's just initialize them with the same values we are initializing them with here in the player frame class. So the blue circle, which is player 1, starts at x is 100 and y is 400. Okay, so here, let's say P1x is equal to 100 and P1y is equal to 400. And then for player 2, which is the red circle, it's 490 for the x and 400 for the y. So that way we already have values for the x and y manually. Okay, so P2x is equal to 490 and P2y is equal to 400 as well. Okay, let me just double check that. It's 100, 400, 490, 400. Okay, save. And then let's go back to the player frame. So now we are ready to receive the information. So we put that in read from server. Okay, so all right, so try catch IO exception ex okay. System.out.println IO exception from RFS, read from server run. Okay, so what do we put inside the try part? So in the try part, we want to read the doubles being sent to us, and then we want to use that value to set the x and y coordinates of the enemy, right? So we put in a while loop in here, while true, so that we can constantly receive the values. Enemy dot set x, and then we say data in dot read double. Okay, so this sets the x value of our enemy, the enemy sprite, and then we do the same thing for the y coordinate. Okay, so if you remember in the finished product, when we run the game server and then we run the player frames after, the windows for both players are only going to come out if both players have already been connected. Okay, so right now that's not what is happening. Okay, so if we run the game server and then we run the first player, okay, the player number 1 GUI comes out immediately. So what I want to do here is I actually want to have player 1 wait until the other player connects before its GUI also comes out. So how do we do that? Okay, so what we can do here is when we connect to the server, so here in the player frame class, when we connect to the server, we read an integer, which gives us our player number, right? And then after that, what we could do here is we could initiate another read, okay, which essentially tells the player to wait for another piece of information from the server before it actually continues, right? Because whenever we have a read, we actually have a block, right? We pause in that section and then we continue only when we receive the information. Okay, so let's go ahead and do that. Okay, so before we continue, make sure that you close any of the running processes, the windows or the server. Okay, so let's make sure we terminate that. Okay, so here in the read from server inner class of player frame, let's create another method. Okay, so let's call this one waits for start message. Okay, so what are we going to do here? First, we need to put in a try catch because we will be reading some information from this method. Okay, so IO exception dx. Okay, then we just say system.out.println IO exception from wait for start message. Okay. And then inside here, I just want to go ahead and read a string from the server, which is going to be the message that it gives me to tell me that we can go ahead and start. Okay, so let's see. I'll create a string. I'll call this one start message, and then I'll say data in dot read UTF. Okay, so until I get that actual string, we won't be able to continue. Okay, and then once I get that string, I'm just gonna go ahead and print it out. Okay, system.out.println message from server. Okay, and then we say start message plus start message. Okay. All right, so I have a typo here. IO exception. Okay. So when do we call this? So this is a method of the read from server class. So we go up here to the connect to server method. The first thing we receive is the player ID. Okay, it actually gets sent right away here in the game server inside accept connection. So once the player connects, we actually send out the player ID right away. Okay, so after we create the runnable objects, the RFS runnable, to be more specific, RFS runnable, okay, which has that new method we created, wait for start message, okay, which then waits for a string to be sent by the server. Okay, so after we receive our player ID, our player frame actually isn't going to continue until we actually receive that string now. Okay, so now we are waiting for a string. So when do we send that here in the game server? Okay, so we want to make sure that we don't send that string right away. So we're sending the player ID right away, but we only want to send that string when both players have already connected. Okay, so we want to wait for player 2 to connect first before we actually send that string to both player 1 and player 2. So let's go here to the write to client inner class first, and then let's create another method. So this one will be called send start message. Okay, so let's put a try catch here as well. Okay, so try catch IO exception ex. Okay, system.out.println IO exception from send start message. Okay, so inside this method, we want to go ahead and send the start message. Okay, so you can just say something like, let's see, data out. Oops. Data out dot write UTF. We'll just say we now have 2 players. Let's say go. Okay. So when do we send this? Okay, so the that's actually what's very important here. The time when we actually send this message. Okay. So let's go up here to the accept connections method. So send start message is a method of our write to client object. Okay. So we have our fields here for the write runnables, P1 write and P2 write runnable. So we want to make sure that we send the start message only after player 2 has connected. So we actually do that here. Okay. So inside the else clause, which is going to run when the second player is connected, we want to go and say P1 write runnable dot send start message, and then we want to do the same thing for the second player, right? P1 write runnable dot send start message. Okay, so here once player 2 has connected, player 1 can now also continue. Okay. All right. So let's test that out. Okay. So we run this. We run the game server. Okay. So waiting for connections, and then we run the first instance of the player. So as you can see, we've got the output window for the player 1 player already, but we don't see the GUI yet. Okay. That's because player 1 is currently here in the wait for start message method. So it's inside here waiting for the server to send the string that is essentially the message for starting. Okay. So we run another instance. So at this point, okay, we run it, and then we see both GUIs. Okay. Because it's only when player 2 runs that we actually send out that start message. So player 1 now actually gets to continue its code. Now player 2 actually continues right away because after it connects, it gets sent the start message right away. And then if we look at the output windows here also, we do see the actual message. Now it doesn't actually have to be a string, it could be anything. The point here is that you initiate a read so that the player is going to wait until you get that information. I mean, it could have been an integer. If you receive an integer, then you go ahead and start. Okay, but I wanted to use a string just so we could have an actual message that gets displayed in the output window. All right, so now we can go ahead and start the threads for sending and receiving the X and Y. So let's just go ahead and close the processes first here. Okay. All right. So here in the game server, we want to go ahead and start the threads for the reading and the writing once both players have already connected. Okay, so right now these run methods aren't actually running yet because we haven't created the threads yet for the runnables. Okay, so when do we want to start the threads? Well, we want to start it when both players have connected. So we actually go back into the else clause here where we send the runnables. Okay, so when player 2 has connected, then we could go ahead and start the threads for reading and writing to the client. Okay, so here let's go ahead and start the read threads first. So I will go ahead and create a read thread for player 1. So this is going to be a new thread. And then we pass to it the read runnable for player 1, P1 read runnable. Okay. And then we do the same thing for the read runnable for player 2. Okay. So P2 read runnable and read thread number 2. Then we go ahead and start those threads. Okay. So read thread 1 dot start. And then read thread 2 dot start. So I will start the read threads first so that the server is ready to read information right away. Okay. Yeah, and then after this, we go ahead and start the threads for the write runnables. Okay, so let's call this one write thread. So you want to pass p1 write runnable. Okay, and then we've got write thread number 2. So you want to pass to it p2 write runnable, and then you want to start the threads as well. Okay. So it's important that we start the threads only after both players have connected, right? Because if we start player 1's threads right away, it could be writing already, but player 2 isn't ready to receive the information yet. So we might run into some problems there. So here we see the importance of this send start message, which allows us to synchronize when the threads are going to start. Okay. And then after that, we have to go ahead and start the threads on the player frame side as well. So we want to start the threads after we receive the message, right? So we go back to wait for start message here. So after we receive the message that we are ready to go, we can go ahead and start the threads already. Okay, so thread, read thread, and then okay, so it's going to be a new thread, and then we pass to it the RFS runnable. Okay, so this is our instance of the runnable for reading. Okay, and then we have write thread is equal to new thread, and then we've got in this case the WTS runnable. Okay, and then we say read thread dot start and write thread dot start. Now there's one more thing I actually have to add. If we go to our run methods here in the player frame, so in the read from server runnable, we are setting the X and Y for the enemy player sprites. And then here in the write to server run method, we are sending the X and the Y of the me player sprite. But if you recall, here in the main method, we are actually calling connect to server first before we set up the GUI. Okay, so we connect to the server, and then we where is that? Okay, so we connect to the server, and then we get our player ID, and then we wait for the start message, and then once we get the start message, we go ahead and start the threads, which will then try to access the me player sprite to get the X and the Y, and then it will try to access the enemy player sprite to set the X and the Y. The problem here is the enemy and the me sprites only get created here in the setup GUI method. Okay, so if we connect to the server right away and then try to access me and enemy before we set up the GUI, we are going to get a null pointer exception here because we actually haven't created the me and the enemy objects at that point in time. So I just need to go ahead and put a checker here. So if me is not equal to null, and we can go ahead and execute these instructions. Okay. So basically, it's going to wait for the me object to actually be created before it actually executes these two method calls in particular. And then we do the same thing for the run method in read from server. So we have to make sure that enemy already exists. So if enemy is not equal to null, then we go ahead and try to access the enemy object. All right, so I think we're ready to go now. Okay, so let me run the game server. Okay, so far so good. Then let me run the first player. Okay, so no GUI yet. And then let's go ahead and run the second player. Oh, sorry, I ran player sprite. I need to run player frame. Okay, so second instance of player frame. There it is. Okay. So far so good. Let's see if I start moving the up and down arrow key. So I'm in player one. I'm the blue square. So up there. So I'm also moving in player two. And then if I go to player two, if I start moving my red square, so I should be moving in player one as well, and there. All right.